Good morning, everyone. As you can see, it's a joint presentation together with Giada Landi from Nextworks. By the way, my name is Raul Muñoz from CTTC, and we are going to present the enablers that we are defining for management and orchestration of 60 networks, and basically those ones that has been defined in the framework of task 2.3 in Work Package 2 and also in Work Package 6. So let's start with task 2.3. As you can see here, the target is the multi-stakeholder intent-based end-to-end service management automation. So the idea is that the goal, let's say, or the scope is precisely the interaction between the network and the application layer in a multi-stakeholder scenario, basically by making use of a network as a service approach. The main idea is that we can define the way that the services of a network operator can be exposed to third parties, and of course by making use of user-friendly APIs based on intent. So the network layer that we consider is an evolution of the 5G communication service provider that was proposed in 5G. This evolution, we name it 6G digital service providers, where basically the main idea is that beyond the network services that are traditionally offered by a network operator, we could also consider cloud resources, AI resources, or services and applications. And at the application layer, the idea is to consider also multi-stakeholder scenario composed by verticals, OTT, hyperscale marketplaces, or applications provider. So this is the automation framework that we have been discussed. At the bottom, you can see the resource provider. Basically, the main idea is that we have autonomous resource management domains, not only at the network level, such as the RAN, the core network, or the transport, but also for AI, for cloud, or also for applications. On top, we have the capability operator. The capability operator is a way that we have also considered in Hexa-X-II to extend the network operator, because we are not, let's say, managing anymore only network resources, but also cloud, AI, and application resources. And that's why the idea was to also change the name to capability operator, that is in charge of providing this autonomous service management of the capabilities. On top, there is this digital service provider that is the interface with the application layer. So it's the one that exposes and manages the services that are provided by the operator to the third parties. And third parties, as you can see, we consider aggregators that can be OTTs, hyperscale marketplace, telco consortiums, that are those ones that are interfaces with the different DSPs, but also, and of course, they offer the services to the verticals and application service providers that are making use of the services from the aggregators. But also, we are considering verticals that are directly interfacing with the digital service provider. The interfaces between the tenants and the digital service provider is based on intent, and also, as you can see here, we have also considered a specific interface between the DSP based on intents in such a way that, following a peer relationship, it is also possible that the DSPs can interact each other and provide an end-to-end service. Regarding this multi-stakeholder approach, as you can see, the digital service provider and the capability operator is considered as a single administrative, but the resource providers can belong to another party. So basically can be provided by different providers. This is the architecture that we have considering to deploy this intent-based digital service manager that we have seen in the previous slide. Basically, there is one part related with the intent management interface that have different functionalities related with the parser of the intent, also the way that we can expose the capabilities, the CRUD, the intent CRUD, activation of the intent, and also the report. It's also very important to highlight that the customers, they also get a report after the fulfillment of the intent. The second key element is the intent fulfillment, and it is composed by several functionalities that are precisely on that direction. So the first one is translation, to map the high-level goals in an intent to the specific executable actions in order to meet the KPIs and the KPIs that are contained in the intent. Also the feasibility check, how we can manage a per-check that the intent that we are going to fulfill is feasible. Also the governance and the coordination service. In Hexa-X-II, the way that we have agreed to fulfill an intent is precisely based on a closed loop. So that means that each intent develops one or several closed loop that are in charge of the fulfillment of the specific KPIs and KPIs by providing the whole elements that are considered in a closed loop. So the monitoring, the analytics, the decision, and also the reconfiguration in case that the KPI is not met. There is also another part related with intent reporting that includes information on the efficiency check, fulfillment, and conflict information. And finally, the last part is more related with the service portfolio. So what kind of services are exposed to the clients and also the profiling of these third parties. So these are the specific enablers that we have proposed in order to meet the architecture that you have seen before. As you can see, there are a total of 9 enablers. So there are enablers. The first, for example, this enabler number 1 is intent translation and provisioning. That is related with the mapping of the intent to the specific actions and also the provisioning. This one is human machine intent interface design. So in order that allows basically to compare the specific translation that is performed with the actual behavior. Intent replacement, so the specific that is dealing with the placement of the resources when an intent is requested. The third-party services, it's also very important because, as I said before, we also need to the services, so the SLAs that are feasible and also those ones that have been contracted by the third parties. Intent reporting, in such a way that all this information about the intent, so the KPIs and KPIs that are monitored and the fulfillment is also reported to the customers. Data fusion mechanism based on telemetry data. It is basically covering the closed loop, so the monitoring, but also the analytics of the KPIs and KPIs. Declarative intent reconciliation. So in case let's say the KPI and the KPI does not meet, we need to also change it. The coordination of the closed loop, of course, because there are many closed loops. And in case that there is a conflict, the intent conflict administration. So as you can see here, basically we can map all the different enablers that have been proposed are mapped to the high-level architecture that you have seen before, and more or less there is a very good coverage in such a way that we can cover all the functionalities that are proposed. So that's all on my side. Now I will give the floor to Giada.
Yes, thanks, Raul. So I will go now into the definition of the enablers that we have specified for the management and orchestration functionalities of the 6G architecture. We started from a list of objectives to improve the automation of the network, in particular going through the programmability of the network itself, and we defined a specific framework for this based on the concept of cloud-native microservices that can collaborate to basically reconfigure the network in an automated manner. Of course, for this, we need a logic and intelligence. And the idea is to use AI and ML techniques in support of this. We will be able also to maximize and optimize the energy efficiency and the sustainability of the system. A system that is very distributed and in this sense is fundamental to orchestrate in an end-to-end manner the entire continuum, cloud, edge, up to the extreme edge and the IoT devices. The other fundamental point is clearly the trustness and the user-centric approach. And this is why for the interactions between our components, we decided to use a Trustworthy and a user-centric integration fabric that enables also the concept of multi-tenancy, and the SLA assessment continues through the entire service lifecycle. How to automate everything? Here, the fundamental concept is this zero-touch closed-loop automation that guarantees the assurance of the service and of the network performance, guaranteeing, of course, the compliance with the KPIs, but also with the KPIs, while reducing the overall operational cost of the network. If we go now into more detail about the single enablers that we have defined for each single objective, we start from the objective around programmability, flexible network configuration, and monitoring. And we can identify 2 key enablers for that. in particular the programmable and flexible network configuration through SDN controllers, mostly based on the cloud native approach, for the programmability of the network in a very dynamic manner through open interfaces and APIs that follow standards, so that we can interact in an interoperable manner with the network components. Of course, we have also the other direction, so the monitoring and the telemetry related to the network metrics. This is done through a pervasive monitoring platform that is able to collect the data in real time, and this is critical to enable a faster response to potential security or performance issues that can happen at the network level. And also in this case, the compatibility with multiple protocols is critical. If we go on to the next objective, that is the trustworthy management and integration fabric. In this area, we have defined two technical enablers that you can see here. The integration fabric itself that enables the interaction across the different components of the management and orchestration system in a very programmable manner, based on a cloud native paradigm that is based on the service-based management architecture concepts. This means that we are somehow refactoring all the connectivity models of the various components of the management and orchestration framework, and this enables basically a cross-domain connectivity of this service. And this is very aligned with the ETSI ZSM concept of cross-domain integration fabric. Trustworthiness, it's clear that we need to consider how to include in this ecosystem the third parties and the users. And this is why we adopt a user-centric approach where third-party subscribers can actually enjoy very personalized service experience, of course, in compliance with the end-to-end regulation. The point is also how to guarantee the SLAs from the translation of SLA parameters down to the monitoring, the assurance, including also the possibility to monitor not only the key performance indicators, but also the key value indicators and the trust level agreements that are in place. If we move on, we can focus on the interdomain and intercomputing management objective that is associated to the possibility to handle in a joint manner decisions that are crossing several domains, potentially based on different platforms, potentially assigned also to different administrative domains. This is why we are proposing solutions based on hierarchical approaches for the decision making, the adoption of AI and ML techniques for the optimal resource allocation and load balancing, of course, using also predictions about the future requirements on the end-to-end platform. And for federation, we are investigating the adoption of distributed ledger technologies for the multi-domain interactions. If we go to the next slide, the key topics of sustainability and trustworthiness applied to the AI ML based control. Here we are investigating solutions for the intent-based management with IML algorithm that are taking into account aspects related to the energy savings and the continuous assessment and verification of the SLAs. Algorithms for optimal resource allocation in an adaptive manner, considering the current network condition and service requirements, but also sustainable MLOps that optimize the process of the machine learning training, also considering the energy consumption implications. And of course, federated machine learning. This is basically, again, in order to save energy and also to enable collaborative AI across multiple domains with privacy concerns. If we go to the next slide, still on this topic, we have other two enablers. One is the trustworthy machine learning based control, and the other one is the network digital twin. Here we are investigating various technologies related to machine learning related to the security aspects, related to the privacy of the data, even in multi-party scenarios, and related to explainability. The digital twins are basically a way to improve the control of the network, also providing a sort of environment where we can validate the decisions before their enforcement. And if we go to the last slide, that is on the automation aspect through this closed loop governance and coordination, the idea is to deploy in a very dynamic manner closed loops that are adapted to the particular target at the network level, at the infrastructure level, at the service level, using AI and ML techniques wherever this is needed, for example, for prediction, for cognitive closed loop, the possibility to use digital twins to preliminary validate the decisions, and a critical point is the coordination among multiple closed loops to identify potential conflicts, to mitigate them, and where possible, even to resolve them. There are several approaches that we are investigating, the delegation and escalation, for example, in case of hierarchical closed loop, the collaboration across peer-to-peer closed loops, the possibility to share the knowledge among multiple closed loops, and so on and so forth. So this is basically an overview of what we are investigating and proposing so far. And this is an ongoing work. You can find more details in our deliverables available on the website. Thank you.